Hello everyone, today in this video we will be discussing the fifth module of maths, and in this module we have two topics. First one is about joint probability distribution and second is about sampling theory. Okay, the first topic is very short and easy as compared to the second topic, so let's discuss each one by one. And before that, if you like this video, hit the like button and don't forget to subscribe to my channel. So in joint probability distribution we have these formulas, and I'll be taking one example and trying to solve each formula by taking the numerical values also. Okay, so the question you can expect of this type, here we have the joint probability distribution of x and y. Okay, the x and y joint probability distribution will be given, and we have in this table x values as this one 1 and 5, and y values are -4, 2 and 7. Okay, and in between we have these 6 values corresponding to each row and each column. Okay, so if we have 2 rows and 3 columns, the total number of elements in this cell will be 6. Okay, so what we have been asked to find out is firstly the marginal distribution of x and y. See, even if they don't ask you to find out this thing like marginal distribution, you'll still need to find out this one for the rest of the questions. Okay, so the first thing what you need to do is, whenever you get this table here for joint probability distribution, firstly you have to find out the marginal distribution of x and y. Okay, see, let's see how to find out the marginal distribution of x and y. So see here, this table I have redrawn here, and here we will be finding out this sum. Okay, this sum means 1 by 8 plus 1 by 4 plus 1 by 8, and that will be writing here. Okay, and this sum 1 by 4 plus 1 by 8 plus 1 by 8, this sum will be writing here. In the same way, I will be finding out the sum for each column. 1 by 8 plus 1 by 4 is 3 by 8. 1 by 4 plus 1 by 8, 1 by 8 plus 1 by 8. Okay, now after we get these all values here, that I will be writing down in a separate table. Okay, like for getting these values, what I did is I added the y values, right? Means see here, the y value for this one 1 by 8, and y value for 2, and y value for 7. Okay, but in the marginal distribution, since I added the y values but I got for x values, right? See here, for 1 I got these values, so I will be writing here under 1 by 2, the sum is 1 by 2. Similarly for 5 I got the sum as 1 by 2, so under 5 also I will be writing 1 by 2. So don't confuse that. We are finding the sum for each y value, but since we had got for x value, we will be writing the under the x value. Okay, so take it simple here. We are doing for the first row, finding this sum and writing, just exclude this value. Under this one, write this one. Same thing for the next one also, we are doing for this one, find out this sum, write here and exclude this one, and write under 5 1 by 2. Alright, that's the marginal distribution of x. Okay, same thing we will be doing for y also. 1 by 8 plus 1 by 4 is 3 by 8, so under -4 we will be writing 3 by 8. Under 2 we will be writing 3 by 8, and under 7 we will be writing 1 by 4. Right, this is the marginal distribution of y. Okay, that was the first question, the marginal distribution of x and y. Alright, then the next one is ex and ey. Ex and ey, what's the formula? Ex is equal to x into f of x, the summation of x into f of x. Okay, so this is nothing but the mean value. Okay, so after this point we will be not considering this table. Okay, for most of the questions we will be looking at these two values only. Okay, now see here, what is e of x? E of x means x into f of x, that's summation. Now in this, what is x value? X value is 1. What is f of x? It's 1 by 2, right? So we'll be multiplying 1 and 1 by 2 and writing here, then plus x into f of x. 5 into 1 by 2 will be multiplying and writing here, and finally adding these both values. Okay, that will get us 3. Same thing we will do for the y also, to get e of y, that is y into g of y. Okay, multiply these two values, then we will get 3 terms here which will be adding to get the e of y value. Okay, this is for the e of x and e of y. Next, what they have asked is v of x and v of y, and hence sigma x and sigma y. Let's look at these formulas here. V of x is equal to e of x square minus e of x whole square. Okay, see here we have two terms, e of x square and e of x whole square. What is e of x? This one we had already got here. We will be substituting that value and finding the square. But for the first term, e of x square, this is a new term for us. Let's see what it is. that is nothing but x square into f of x. Like we did x into f of x, we will find x square, then multiply with f of x. Okay, so let's see how to do that. E of x square minus e of x whole square, this we already know, it is 3 here, so 3 square will be writing 9. Let's focus on this one now. X square into f of x, right? So what is the x values and f of x values? 1 into 1 by 2. So therefore what will be writing? 1 square plus 1 square into 1 by 2 plus 5 square into 1 by 2. Okay, then we'll be adding. Okay, same thing we'll be doing for y also. Minus 4 square into 3 by 8 and 2 square into 3 by 8 and 7 square into 1 by 4. Then we'll be adding all those values to get e of x square. Okay, after we get e of x square, substitute that value here and then subtract with e of x whole square. Okay, then we'll get v of x. Same thing we'll do for v of y also. Then what's the next question? They had asked us to find out the sigma values, right? Sigma x and sigma y are nothing but the root of the vx value we got here and root of vy value which we got here. Okay, that's very easy. The next one is e of xy. E of xy means, see here, sigma 2 times you have to find the summation of x into y into j. Now let's see what is the j value. For that we will be looking at this table. Okay, in this table, what is firstly we need to know what is j of 1 1. J of 1 1 means first row, first column, that is xi, x1, y1 into j11. Okay, this is the x value, this is the y value and corresponding j value. These three we have to multiply. 1 into minus 4 into 1 by 8. This is for the first element. What will be for the second element? 1 into 2 into 1 by 4. Okay, 1 into 2 into 1 by 4 plus 1 into 7 into 1 by 8. 1 into 7 into 1 by 8. Alright, like that we'll be doing for the second also. 5 into minus 4 into 1 by 4 plus 5 into 2 into 1 by 8 plus 5 into 7 into 1 by 8. Okay, then we'll get 6 terms here. After that multiplying and adding, we'll get the final answer here. Okay, so e of xy they had asked, so we did x into y and jij will be the constant here. Okay, if they ask e of xy, we have to multiply x and y along with j of ij. Alright, then if they ask covariance of xy, in this case what we have to do? This is nothing but we have to substitute what we have already found out. That means e of xy, which is the previous one, minus e of x into e of y. E of x and e of y we have already found out here. So we'll be choosing these two values, 3 and 1, and then we'll substitute in this place. Okay, 3 and 1, and here what we got? E of xy. E of xy we found out here 3 by 2. Okay, so 3 by 2 minus 3 into 1, that is minus 3 by 2. That is for the covariance of x and y. Now we have covariance and we have sigma values also. We'll substitute to find the probability of x comma y. Okay, the next one is e of 2x plus 3y. Observe here carefully what we did when we had exy. This is same as this one, e of xy. When we had e of xy, what we did? 2 times summation x into y into j, right? This one was done earlier, right? Here, see here we did x into y into j for e of xy. Now instead of xy, what we have? We have 2x plus 3y. So what we'll be doing is we'll be seeing at this table here, and then we need to find out 2x plus 3y, right? So what is 2x? 2 into, we'll be accessing each value first. 2 into 1 plus 3 into minus 4. 3 into minus 4, this we'll be calculating. Okay, what we will get? Minus 10, right? Minus 10 we'll get, we'll write here, then multiplied by 1 by 8. Right, we'll be multiplying it with 1 by 8. Okay, like previously how we did x into y into j, instead of that what we are doing? 2x plus 3y into j. Okay, 2x plus 3y into j. Instead of xy, what we have? 2x plus 3y. And if in the place of 2x plus 3y, if they give 3x plus 2y, we have to find out as they have given 3x plus 2y, then multiplied with the corresponding j element. Okay, like that we will be doing for all the elements. Like for example, second element, if I take 2x plus 3y, right? What is 2x here? 1 into 2. Okay, this is x value, this is y value. 2 into 1 plus 3 into 2. Find out this sum first, then multiply with 1 by 4. that will be for the second term. Like that we have to do for the third term, fourth, fifth and sixth term. Then add all those terms to get the final answer here. Okay, like in this case we'll get as 9. Okay, then we have been asked to find out the probability of x plus y greater than 3. Okay, x plus y greater than 3 means any value we can put for x and any value we can put for y. Okay, means whatever values of x and y I can put to get the sum greater than 3. See here, x value can be 1 or x value can be 2. Here y value can be 1, 2 and 3. Okay, so my condition is x plus y should be greater than 3. If I put x as 1 here, what all values of y I can get? Y should be whatever value of y I put, it should be, the total sum should become greater than 3. So if I put 2 here, it will not become. So I should put 3 here, right? If I put 1 plus 3, it will be 4. So the selected row and the element is, this is the selected row and this is the selected column. So this is one of the valid element. Next element, I can put 3 here plus 1, right? 3 and 1 can't be taken because there is no 3 rows, right? So this is not possible. 2 and 2, right? 2 and 2 is possible. 0, 1, 2, right? This is also 2. So 2 and 2 means second row and second column. Sorry, this is 1, 2 and 3, this is 1 and 2. So 2 and 3 can be taken here, 2 and 2. Okay, 2 and 2 means this one, right? This one, and 2 and 1 can also, 2 and 1 can't be taken, 2 and 2 can be taken, 3 and 2 can also be taken. So these 3 are the selected elements, right? See once more, this is the first row, second row and third row. This is the first and second row. Whatever row number I choose, these are the row numbers. Whatever I choose from among this, if I insert in x and y, it should be greater than 3, right? So if I insert x as 1, then the only possibility is 3. Okay, so 1 comma 3. Then if I choose for 2, I can have two possibilities, 2 and 3, because both will give the answer greater than 3, right? So 1 by 8 and 1 by 8. So I'll be writing 2 comma 2 and 2 comma 3. So these are the 3 selected elements. After we select the elements, then what we have to do? See, after we select the elements, those particular j values we have to add. 1 by 8, 1 by 8 and 1 by 8. Okay, then we'll get 3 by 8. This is the final answer for probability of x plus y greater than 3. Okay. Next they have asked probability of x is equal to 1 and y is equal to 2. X is equal to 1 and y is equal to 2 corresponds to one element only, which is x is equal to 1, y is equal to 2, this element. So this is the answer. This is the final answer. Okay, 1 by 4. Alright, that's the final answer. And x greater than equal to 1, y less than or equal to 2. X is greater than or equal to 1 means x this row is selected and this row is selected. Y is less than or equal to 2, I think, yeah. Y is less than or equal to 2, yeah. Y is less than or equal to 2 means this is the y value which is less than or equal to 2. Okay, so these two rows are selected and these two columns are selected, means all these 4 elements are selected, right? So what we will be doing is we will be adding all these 4 elements. 1 by 8 plus 1 by 8, 1 by 4. 3 times 1 by 4 is 3 by 4. So the final answer will be 3 by 4. In the same way, the variation can happen like x less than or equal to 1, y less than or equal to 2. Similarly, we will do in the same manner, we will make the changes. Okay, and then we will write the answer here. The another one is x plus y greater than or equal to 2. This is also same as this one which we did earlier in the 8th question. X plus y was greater than 3. Here x plus y is greater than or equal to 2. Observe here carefully, it's greater than or equal to 2. So you have to choose those elements also which sum is equal to 2. Okay, those row numbers whose sum is equal to 2, that we will also choose. In this we just choose which are greater than 3. Okay, but here equal also is to be considered. Okay, and find out those elements. These are the 4 elements: j12, j13, j22 and j23. Find out the sum and that will be your final answer. Okay, so this was the first type of question which could be asked under this topic. And the second type is they could ask you to find out the if the x and y elements are independent. Okay, so let's discuss what is being independent means. Okay, in this table, what does x and y being independent means? How to verify that? See here, this is the same table. We have 2 rows here and 3 columns. These are the j elements. Let's see how to find out the independency of the x and y. Okay, so firstly, as I told you before also, what you have to do first, whenever you get these elements, firstly you have to find out the sum here. Okay, marginal distribution. Find out these 3 values sum right here. find out these three values sum and write here. Same thing for column. Okay, and after that when you get this sum and this sum here, then what you have to do, you have to note down the j values. Okay, for independency the first step is to find out the sum, the second step is to write down the individual j values, which are j11, j12, j13, j21, j22, j23. okay, these 6 values we will note down here. Next our step is to multiply this value with this value. This and this value corresponds to which element? This one. If you get the same answer, proceed further. If you don't get the same answer, write the conclusion as x and y are not independent. For example, if I multiply 0.3 and 0.2, what answer I get? This one, 0.06. Same thing for the next row and next column element, which is 0.3 into 0.5, I am getting the same answer. 0.3 into 0.3, same answer. Like that we will be checking for all the elements. Okay, if you get the same answer, that means for all the elements you should get the same answer. Even for one element, if it doesn't get the same answer, we will be writing it's not independent. Okay, when we get the same answer for all the multiplications, then only we will write as those are independent. Okay, so f of x1, g of y1, x1 with y2, x1 with y3, like that same for x2 also. Okay, then we will check with the corresponding j values, we should get all the same values. Okay, then only we will be writing those elements as independent. Okay, and that's it under this topic. Maybe there could be asked more questions which I didn't cover in this video, but mostly these questions are only asked. Okay, so practice this very well and go. Okay, this is the second part of the maths module. So this is the second half, and in here we have two topics, which are, first is about the sampling theory normal problems, and the second part we have students t-test distribution and chi-square distribution. Okay, so in this part we will be discussing about the sampling theory normal problems. Okay, so mostly the questions come from either these formulas, means the questions which come, we have to apply one of the formulas from among these formulas. Okay, so there are totally 9 types, so we will be discussing each type of formula, means for this formula what type of question you can expect. Okay, so let's get started with the first one, which is z is equal to x minus np by root npq. So in this type of question, in this type of problems, what you can expect is a question of the type, a coin was tossed for this many times and the head turned out this many times. Okay, so a thing will be performed, means totally how much time it's performed, that will be given, and how many times a success rate or failure rate happened, that will be given. Okay, so when these two things are given, you have to use the first formula. Here the how many times the total event was performed is given by small n, that's the sample size, and what's the total success time, means how many times it was successful, right, that will be x. Okay, and we have to test the hypothesis that the coin is unbiased at 5% level of significance. Now remember these two numbers from now on. 5% means 1.96 and 1% means 2.58. okay, 5% or 95% also, when they give, it means 1.96. okay, just remember this constant for now. Okay, now we'll be using this constant in the formulas. Okay, so wherever they give 1.5%, right below that 1.96. okay, then the hypothesis what we have to test is that the coin is unbiased. So what we'll be writing first is HO is equal to coin is unbiased. Okay, after writing this, we have to find out the P and Q values. Since they have given how many times it's successful, we will be dividing that by the total number of times, which is 400. Okay, so this will give us the success rate, but before that we have to find out the success rate of the coin being unbiased. Okay, so getting a head is equal to getting a tail, okay, which is 0.5 only in this case. So therefore what we have to find out is, first we will get P and Q, and then we have to subtract with x. This is the x value, means how much time it was successful. So 216, x is 216 minus n is 400 into p is 0.5 divided by npq. okay, 400 into 0.5 into 0.5, right. After multiplying these values, you will get one answer, that's the z value. Now after getting the z value, it's last step, they have asked us to find out the 1.96. so keep in mind here 1.96 and the value which you got here, you have to compare these both values. Okay, if this value is lesser than 1.96, it is accepted. Okay, if the value which answer you get right, that should be always less than 1.96 or the second one, which is 2.58. okay, this for 1%. If they ask for 5%, it should be 1.96. If they ask for 2.99% or 1%, it should be 2.58. Okay, if you get the answer lesser than these both constants, at that time it will be accepted. Okay, if this answer exceeds 2.58 or 1.96, then it will be rejected for the respective case. Okay, so in this case z value is 1.6, which is less than 1.96, therefore the hypothesis, which is the coin is unbiased, is accepted. Okay, this was for the first formula. Okay, x minus np by root npq. Now sometimes they don't give the individual values like success rate and the failure rate. At that time what will be given is the x bar. Okay, means the mean will be given. A sample of 100 tires is taken from a lot. The mean life of the tires is found to be 39,350. Observe here carefully with the numbers, you have to be very careful. Okay, a sample of 100 tires were given, so 100 is small n, and it's found the mean life was found to be 39,350. The mean life is given for what? It's given for sample, right? The mean life of the sample is given as x bar. Okay, so there we'll be writing x bar. Then with a standard deviation of 3260. So this is the sigma x bar. Okay, observe here carefully. For the sample you will be writing x bar for the mean, and for the standard deviation you will be writing sigma x bar. Okay, can it be considered as a true random sample? This is the hypothesis. Okay, can it be considered as a true random sample? That will be writing in h naught. Then from a population with mean life of 40,000. That's why I told you have to be very careful which one is for sample and which one is for the population. For the population, that will be nu. Okay, nu will be for the population and x bar will be for the sample. Okay, and we have to use 5% level of significance. Okay, so first we will be writing the hypothesis, which is sample is a true one, and then we will be writing the formula z is equal to x bar minus nu by sigma x bar. Okay, see here they have not given the success rate and the failure rate, so in this case we can't use this formula because we don't know what is p and q. Okay, here instead what is given to us is x bar, sigma x, and nu. Okay, when these three things are given, we can go with this formula. Okay, substitute the three values in this equation here and we will get minus 0.199. Now we have to compare it with the 5%. 5% means what? 1.96, right? 1.96 you have to compare the final answer which we got. Here we will be taking the mod value. Negative value will be not considered. So taking the mod we get as 0.199. It's less than 1.96, therefore we will accept it. Okay, so it's accepted for 5% level of significance. Okay, this was the second type of question where we'll be given with the sigma x values and the mean values. Okay, and you have to be very careful which mean value we are considering for sample and which one we are considering for population. Okay, after that the third type of question is for this type of question wherein will not be given with sigma x bar. Let's see how the question is. The life x of certain computer is approximately normally distributed with a mean of 800 hours. Now is this a mean of a sample or the population? That you have to know very clearly. Okay, so for that we'll be reading the whole question first, then we'll be deciding what they have given. Okay, and standard deviation of 40 hours. If a random sample of 30 computers has an average life of 788 hours, test the hypothesis that nu is equal to 800 hours is against the alternate hypothesis of nu not equal to 800 at 5% and 1% level of significance. Now see here, it's clearly mentioned that the random sample starts from here. So here what mean value they have given is x bar, and what mean value was previous was for the population. Okay, if you don't read the whole question, suppose that this was not given, at that time we'll consider this as the sample. Okay, so in that way we have to differentiate and choose specifically. Okay, so here what we get is the new value is 800 and the sigma value is 40 hours. This is not sigma x bar. Okay, sigma x bar we have to find out. Okay, here what we have is x bar as 788 and sigma x bar will be finding out. How to find out the sigma x bar? Using the values which have been given. Now observe the formula here. Firstly we will be writing nu is equal to 800, sigma is equal to 40, n is equal to 30, x bar is equal to 788. These are the four things which we have been provided with, so that we can apply this formula. Okay, in this formula we need sigma x bar. How to find out that? The formula is sigma by root n. Sigma is given as this one 40, so sigma is 40 and n is equal to 30. 40 divided by root 30 will give sigma x bar. Find out that value and substitute here to get the z value. After you get the z value, it's very simple. You have to just see, is it less than 1.96 and less than 2.58. What is the answer which you get here? It is 1.64. 1.64 is less than 1.96 as well as less than 2.58. Therefore, we will accept for 5% as well as 1%. Okay, the hypothesis, which is the nu is equal to 800. This is the hypothesis. It will be accepted for 1% and 5%. Okay, that's it for the third question. So I have written here 4 because the formula is used. See what in the fourth I have written. It's not a separate question, but to maintain the uniformity I have written that. Okay, in the fourth I have mentioned this point, right? If it's less than or greater than, we'll accept or reject. So I have clarified in the third question only. Okay, so this for the fourth part. Then the fifth part of the question is about the standard errors. Okay, in standard errors we have 4 types. This is the single value and this for the mean value. Okay, 2 types of question can come. Either you will be given with a p or q value, or else you will be given with the mean value. All right, based on that we will be going on with this formula or this formula. Let's see an example here. The fifth one, for the single values we'll be considering first. Okay, so the question goes as follows. A sample of 900 days, which is small n, was taken in coastal town, and it was found out that on 100 days the weather was very hot. Okay, so total of 900 days were observed, and in that part of 900 days, which is 100 days, means 1/9 part of the total sample was found out to be, the weather was found out to be very hot. Okay, so what we have to find out is the probability limits of the percentage of very hot weather. See, in the previous cases we are testing the hypothesis, right? In this case what we are asked is to obtain the probable limits. Obtain and test is very different. In test we will just see if it's lesser or greater value. In probable limits we will find out what is the actual probability. Okay, in addition to that, what we have been given is the total number of days and the success rate. When we have been given with the success rate and the total number of days, at that time we have to go with the formula of P and Q. Okay, P can be found out by 100/900 and Q can be found out by 8/9. Okay, the total number of the sample size is given as 900, so n will be 900. Okay, and P is the success, which is 100/900, which is 1/9, and Q is 1 minus P, which is 8/9. After getting these 3 values, we will be applying this formula, P plus or minus 2.58 into root PQ by n. Okay, we'll be using those values to find out the answer here. Okay, and since we have found out for 99%, we took here as 2.58. Okay, and if you have to find out for 95%, the same formula, just we'll be using 1.96 here. Okay, this was for the single values. If they have given the mean values, we'll be using the formula for the average. Okay, a random sample of 400 items, which is n, chosen from an infinite population, is found out to have a mean of 82 and standard deviation of 18. Observe here carefully, we are choosing from a random sample. Sample is given, so it's not population. Of 400 items from an infinite population is found to have a mean of 82 and standard deviation of 18. So here we are getting the mean and the standard deviation of a sample from the infinite population. So ultimately it's the mean and the standard deviation of the sample. Okay, so that is equal to x bar and sigma x bar. After we get that, what we have been asked to find out is 99% and 95% confidence limits for the mean of the population from which the sample is drawn. Okay, you have to find out the 99 and 95% of the confidence limits for the mean of the population. Okay, same thing as the previous question where we had asked to find out the probable limits. Here also we will have to find out the probable limits. Okay, confidence limits or probable limits, if they give in the question, you have to go with this formula. Okay, n is given as 400 and x bar is 82 and sigma x bar is 18. The formula is, instead of P and Q, what we have is x bar plus or minus 1.96 into sigma x bar by root n. Okay, substitute those values here in this formula, then we'll get the final answer here. Same thing we'll do for the 99% also. This was for 95. Instead of 1.96, what we'll write is 2.58. Okay, so here we will do the same thing, apply the same values here. Instead of 1.96, what we have is 2.58. Okay, then we will get the final answer here. So this was about the standard error. Okay, the fifth type of problem. Okay, so this was for the standard error. Let's move on to the next one, which is the difference of the means. Okay, so in difference of the means, the question can be of this type. A sample of 100 bulbs produced by a company showed a mean life of 1190 hours and standard deviation of 19 hours. So there are two companies, A company and B company. Okay, in A company the mean life is 1190, so it's a sample. Okay, we have taken the sample, so it will be x bar here, and the standard deviation will be sigma x bar, and this is n. Okay, we can take as n1, and this one is x1 bar and sigma x1 bar. Okay, so here in the below A will be writing these data which I have been provided with, which we have been given. So and for the next company, which is company B, 75 bulbs means N2, and produced by a company B shown a mean life of 1230 hours. So this is x2 bar, and the standard deviation as sigma x2 bar. Okay, therefore we have the three values here for company B also, and by using these three values we will be finding the difference. Okay, difference between the mean life of the bulb produced by company at 5% and 1%. Okay, so company A's value will be writing here, n1 is 100, for this it is 75, 1190, 1230, 19 and 120. We will be finding out the difference between these both. What's the hypothesis? Firstly, we will be considering the opposite hypothesis. Okay, means whenever they have asked us to find out is there any difference between the mean life, at that time we will take the hypothesis as there is no significant difference. Okay, based on this we will be finding out if it's true or not. Okay, it will always be taken in this format, there is no significant difference. Okay, there is no significant difference. Okay, and after that we will be proceeding with the formula. Z is equal to, in the numerator we have x1 bar minus x2 bar, and in the denominator we have the square root of sigma 1 square by n1 plus sigma 2 square by n2. Alright, we have these values here, all are given in the question. We will be substituting those values here in the equation to get the final Z value. In the Z value you have to take the mod, so it will be 2.85. We will be comparing with 1.96 and 2.58, right? 2.58 and 1.96. It's greater than 1.96 and greater than 2.58. Therefore the hypothesis will be rejected. Okay, it should be less than that, then only we will be considering that. Okay, so the hypothesis is rejected, so this hypothesis is not considered. So that means there is a significant difference. Okay, there is a significant difference between the mean values of A and B companies. Okay, that's the final answer. So this was the sixth type. This was in this we are given with the mean life and standard deviation, but sometimes they will give the success rate and the failure rate. Okay, for example, in this case also we will be considering two cities, city A and city B. From city A 1000 engineering students came, and from city B 800 came. Okay, it was found that 400 students in each of the sample were from payment quota. So our success rate is what? How many students were from payment quota? Okay, that number they have given. This you have to be very sharp in pointing out what data we have been provided with, and which formula should be applied for the question. Okay, so two cities are city A and city B with 1800, and the 400 is given as the success rate. Then what does the data reveal about the significant difference between two cities? Okay, the same as the previous one, they have asked us to find out if it's a significant difference or not a significant difference. Okay, so what we'll be doing is, first we will be noting down the A and B. What is the n1 value, which is 1000, and b2 is having n2, which is 800. Okay, and after that what's the success rate? 400, right? So what's the probability? P1 we are taking for the city 1, and P2 we are taking for the city 2. In P1 it is 400 by 1000, which is 0.4, and for P2 it is 400 by 800, which is 0.5. Therefore after that we will be taking the hypothesis as there is no significant difference between the two cities. Okay, after that we will be writing the formula P1 minus P2 by square root of PQ 1 by N1 plus 1 by N2. Okay, what is the P value? Here we have the P value, right? P and Q we need to find out. That's not given to us. Okay, This is the capital P1 and capital P2, which you have to find out by the success rate. Okay, but the second thing which you need to find out is small p and small q, right? So for small p, the formula is n1 p1 in n1 p1 plus n2 p2 by n1 plus n2. What is n1 and p1? That we have been given in the question. N1 is the number of students from city A and P1 is 0.4. Similarly, N2 is 800 and P2 is 0.5. Therefore, multiply N1 with P1 and add it with N2 and P2 divided by N1 plus N2. When we do this, we will get the final answer as P as 4 by 9 and Q as 5 by 9. After we get P and Q values, where we will be using is here. In this formula, which if we apply, we will get the final answer for Z1. When we get the answer for Z1, what we will be doing is we will be comparing for 99 and 95%. What were the numbers? For 99 it is 2.58 and for 95 it is 1.96, right? So these two numbers will be comparing. Is 4.23 greater than 2.58 and 1.96? It's greater, so the hypothesis will be rejected. Okay, so that means the hypothesis is rejected since 4.23 is greater than 1.96 and 2.58. Okay, what was the hypothesis? There is no significant difference, and if it's rejected, that means there is significant difference between the two cities. Okay, so this was about the 7th formula. What is the 8th formula? In the 8th formula, what we have is the difference between the means, again the same thing but with a slight variation. In these questions we were testing the hypothesis, right? What question we have been asked is, if we look once more, see here, they have asked the question type. You have to be very clear with, you have to know very clearly what's the question type. Is there a difference? What they have asked, is there a difference? That means we just have to test the hypothesis, right? In the second, the 7th also they have asked the same thing. See here, does the data reveal? In these types of question we have to test the hypothesis. Okay, means if the z value is less than or greater than. But in the other type of question, which is the next one, 8th question, here what we have been asked is, they have clearly mentioned here, find 95% confidence limit for the difference. See, whenever they say find the confidence limit or probable limit, at that time we have to proceed with this formula. Same thing, two companies are here, company A and company B. So a random sample of 1000 workers from a company has a mean wage of 50 rupees, that means x1 bar, and standard deviation of 15, which is sigma x1 bar. And what is the random sample? N1. Okay, that's for the company 1. From another company, what we have is 1500 workers, which is N2. From another company which has a mean wage of 45 rupees per day, which is x2 bar, and standard deviation of 20 rupees. 20 rupees is sigma x2 bar, right? We have 6 values now, n1, x1 and sigma x1, n2, x2 and sigma x2. Therefore, what we have to find out is 95%. 95% means 1.96, okay, for the two companies. So we'll be noting down the values of A and B here. We'll be applying the formula x1 bar minus x2 bar plus or minus 1.96 because 95%, and square root of sigma 1 square by n1 plus sigma 2 square by n2. Apply the values which we have here. Okay, apply these values and find out the final answer here. Okay, these are the probable limits. And if they ask for 2.58 at that time, means if they ask for 99%, at that time just remove this value here and write there as 2.58. Do the same calculation, you will get the values for 99% as well. Okay, this was for then 8th question. See here, 8th question was for the differences. Okay, I have just taken one example to save time. I have just taken the first one, which is the 95%. This one is just the change of the value here, rest all things are same here also. Okay, let's move on to the last one, which is sampling with replacement and without replacement. In both of these we'll be considering with an example. See here the 9th question. The question goes as follows. The weights of 1500 ball bearings are normally distributed with a mean of 635 grams and standard deviation of 1.36 grams. Okay, and this is the population, because in the next part of the question we have been given if 300 samples of size 36. So sample size is 36. It's not 300. Okay, wherever they mention size, that means 36. If this was not mentioned, that means sample size is 300. Okay, here they have clearly told size is 36. Okay, so this is nothing but small n, and this is capital N. Okay, 1500 is for the population, which is capital N, and the mean is for the population, therefore it is nu, and standard deviation is just sigma. Here what we have been given is, you have to find out what is the sampling rate with replacement and without replacement. For that, what we'll be doing is, we'll be writing what is given to us. N is given for the population as 1500, and nu is 635, and the sigma is 1.36. This for the population. And for the sample, one thing we have been given, n is 36. This is the sample size, okay, small n. And then what we have to find out is x bar and sigma x bar. For n, these values are given, the average value and the sigma value, but for sample we have been only provided with one value. Okay, we have been given with only one value, which is small n. Therefore we have to find out the rest two values, which is average and sigma. So there are two cases possible. In the first case, we will be seeing for sampling with replacement. In replacement, what is the thing is, two things we need to find out, right? X bar and sigma x bar. So what is the value of x bar here? That is the same as the mean. Okay, with replacement, that will be same as mean, which is 635. So here the value of x bar is also 635. Okay, and what is sigma x bar? Sigma x bar value is sigma by root n. Sigma is given as 1.36, and the root n is root of 36. Find out the value here, you will get the value for sigma x bar. That's for the sampling with replacement. In without replacement, the first one is same here, x bar will be same, but sigma x bar will differ. Okay, that will be c into sigma by root n. Here we will get the same answer as this one, multiplied by capital N minus small n by capital N minus 1. Okay, so capital N is 1500 minus 36 by 1500 minus 1 into the value of sigma by root n. Okay, to students t distribution, we have three types of formulas under which the questions could be asked. This is the mostly asked type of formula question. So let's look at what is this one. In this type of question, will be given the question of this type: 10 individuals are chosen at random from a population, and their height are found to be these values, and we have to test the hypothesis that the mean height is 66 inches. Okay, we will be given with two values, t value and df value. Okay, so how to approach this question is, first we have to write down how many individuals are there, means 10 individuals, and what's the mean given. Mean is given to be nu, which is 66. Okay, this is the mean of population. We have to find out the mean of the sample. Okay, that is x bar. X bar is equal to summation of all the values which they have given divided by 10. Okay, that's the number. Then we'll get we'll get a mean value. What we have to do is subtract the mean value from individual elements. Okay, and then square it. Right, this is the individual elements, subtract it from the mean and square it, and then add it. Okay, so what's the main formula is, t is equal to x bar minus nu by s by root n. Okay, so what we need to find out is s here, because x bar we know, nu we know, and root n also we know. We just need to find out s. So what is the formula of s is, s square is equal to summation of x minus x bar square by n minus 1. So for that we found out the summation here. We'll be using this summation value here in this equation. N value we know, so 10 minus 1 is 9, and we'll multiply it with this value to get s square value. Then we'll find out the s value by taking the root of s square. Okay, this is the s value. After you get the s value, we'll substitute back in the t equation to get the t value. Then finally we'll be comparing the t value with the given t value. Okay, this is the given t value 2.262, and the t value we got is 1.89. we'll be writing here 1.89 and comparing with 2.262. then if the value which we got is lesser than the given value, then hypothesis is accepted. Okay, the next type of question is the difference of the means. So here the two scenarios will be given. A group of boys and girls were given an intelligence test. The mean score SD number, and in each group is are as follows. Okay, see here the mean standard deviation and the n is given of boys and girls. Here what we have to find out is the difference of the means of the two groups significant at 5% LOS. 5% means 1.96. Okay, we have been given with the t and df value. Here first we will write the hypothesis, there is no significant difference, and then we will be writing down what's given, x1 bar, s1 and n1. Okay, like that, x2 bar, s2 and n2. Okay, then we will be finding out the the equation is x1 bar minus x2 bar by s into root of 1 by n1 plus 1 by n2. Okay, S value is, the formula will be different for this one. Here it will be n1 s1 square plus n2 s2 square by n1 plus n2. S1 and n1 we have, s2 and n2 also we have. We will substitute to find out the value of s square first, then s. Okay, after we get the value of s here, it's nothing, just we have to substitute back here to get the t value. Then we'll comparing that, then we'll compare the t value with the given t value. If it's less than that, then it will be accepted. Okay. The last type of question can be of confidence limits for 95 or 99%. Okay, so the formula is x bar plus or minus t of 0.05 for 95% and t of 0.01 for 99%, and here s by root n. Everything will be given to us. We just have to substitute the formula. See here, a sample of 11 rates from a central population has an average blood viscosity of 3.92 and SD is also given to us. See, this is the average, which is x bar, and the SD is also given, which is 0.61. We have to establish for 95%. Okay, and 11 samples, so n is also given as 11. We'll be writing here these three values and substituting back in the main formula, and then we get the answer for t of 0.05. Okay, t of 0.05 is given here. Okay, in this question we are finding the probable limits. Okay, in the previous two questions we are just testing the validity. Okay, coming to chi-square distribution, we have the main formula. Chi-square is equal to OI minus EI square by EI. So let's see what it is. And if chi-square is less than the chi-alpha square, then we'll accept it, else we'll reject it. Okay, so the question can be of this type: 4 coins are tossed 100 times and the following results were obtained. Okay, number of heads are given here and how many times the number of heads were obtained, that are given here. Okay, what we have to do first is, if they have not given 100 here, what we'll do, we'll add all the frequencies. Okay, we have to add all the frequencies and we'll get here 100. Now what we have to do is, we have to apply the formula. The formula is, see here, chi-square is equal to OI minus EI. What is OI? OI is nothing but the frequency here. Okay, these are the OI values, and we have to subtract it from the EI. What is EI? To find out EI, first we have to find out PI. Okay, from finding out PI, we'll multiply with how many number are there, like 100, then we'll get EI. Okay, this is the formula for EI. Now how to find PI? Here what they have given is fit a binomial distribution. They can give any type, like Poisson distribution or other types which you learned in the previous module. Okay, so any type of distribution will be given. We have to find out the probability values. P and Q is it's unbiased coin, so it's 0.5 and 0.5. And then what we'll do is, the probability function P of x is NCX P power x Q power n minus x. We'll substitute these values for 0 to 4, and we'll get the probability values. How to find out the E values? E is nothing but multiply the how many times it has occurred, means total number of times, into the probability value. Here we will get 5 values, and then we'll be using those values in this table. OI is nothing but the frequencies, and for each frequency how much EI you got, that you will write here. Alright, first we have to subtract these both. And then square it, and then at the same time divide by EI also. Okay, we have to not do at the last, we have to do for individual elements only. Okay, after doing that, we'll get 5 terms here, add it, that will be the chi-square. Then we have to compare with the given chi-square value. In this question, the given chi-square value is 9.49. Therefore it's accepted, since the value of chi-square is less than chi-alpha square, and hence the fitness is good.